Hi, in this video, we're going to continue our lesson about equations. And let's go to uh, a theorem here, which is which we will call properties of equality. So we have four properties of equality. For I, we have uh, the so-called addition property of equality. So if we have A and B and C to be real numbers, let's say A, B, and C be real numbers, and assume also that if A is equal to B, okay, now take note that you can choose any C, okay, you can choose any C, okay, choose any C or choose any number. Assume that A, B, and C are real numbers, where C, you can choose any C, real numbers, and assume also that A is equal to B. Then according to this theorem, A plus C is equal to B plus C. So take note, okay? Take note, if we have A which is equal to B, if we are going to add a real number C to both sides of the equation, we have plus C and plus C, then this new expression to the left will always be equal to the new expression to the right. So even if you add any number to both sides of the equation, make sure that the numbers are the same, of course. So let's say you have C and you add C. So both sides will always be equal. So it's just like a fulcrum. If we have uh, two objects of the same weight, and if you add another object of the same weight to both sides, of course, we have still a balanced uh, so now that's an analogy for this property. Okay. Let me give you some examples. So for 1i, so let's say you have, of course, this is very obvious. If 5 is equal to 5, then if you add, let's say, 2 to both sides of the equation, so of course, both sides will also be equal, right? Because this one becomes 7, this one becomes 7, and of course, the right side will also be equal to 7. So, yeah. If you want to add any number to both sides of the equation, you'll get the same answer. Okay? Another example will be if x plus, let's say, you have x which is equal to 7. Let's say another number. Okay, let's say 9. If you have x equals 9, if you add any number to both sides of the equation, let's say 4. So if you add 4 to both sides, still you have the same quantities. So x plus 4 will always be equal to 9 plus 4. So that is addition property of equality. Okay, similarly for 2i, that is 2i, and then if a, b, and c are any numbers or any real numbers, and if we assume that a is equal to b, then if you subtract c to both sides of the equation, the left side will always be equal to the right side. Okay? So, example, if you have 8 Of course, we know 8 is equal to itself, right? Now, um, if we subtract, let's say, 2 or let's say 3 to both sides of the equation, so 8 minus 3, so which means that the left will always be equal to, or in this case, the left is equal to the right. So this one is, of course, 5, and this one is 5. So we get the same answer when we subtract the same number to both sides of the equation. Remember, we will apply these properties later. We will use this one to solve simple equations. Okay, similarly, if you have this one, you have y equals 12, and you're going to subtract 6 to both sides of the equation. So y minus 6 will always be equal to 12 minus 6. So if you subtract 6 both sides, so you'll get the same quantities. Y minus 6 is just the same as 12 minus 6. So 12 minus 6 is 6. Okay, so that is property 2i. For 3i, this is called multiplication property of equality. Now, it's just the same. If a, b, and c are real numbers, if a, assume also that a is equal to b, then if you multiply c, both sides of the equation, a times c will always be equal to b times c. Example, so let's make it simple. You know 2 is equal to itself, right? Now if you multiply, let's say, 4 to both sides of the equation, so 2 times 4 multiplied to both sides, so of course you get the same answer, right? 2 times 4 is 8, then 2 times 4 is 8. So you get the same answer. So which means that the left is equal to the right side. So meaning the left is equal to the right, equivalently. 2 times 4 is equal to 2 times 4. Okay, we will use that idea. Now, if you multiply different numbers to both sides, so it will not be equal. Okay, so be careful. You have to multiply the same number to both sides of the equation. Another is this. So if you have, let's try negative. Okay, let's say 3 is equal to 3. Of course, if you multiply, let's say, negative 5 to both sides, so 3 times negative 5, 3 times negative 5, still the answer is the same. This is negative 15, and this one is negative 15 as well. So you get the same answer if you multiply the same number, in this case negative 5. Okay, when you're going to apply this one in different expression, let's say, so let's say 2x equals 10. Now, if you multiply 4, let's say another number, let's say 6 to both sides of the equation, so this becomes 2x times 6 is equal to 10 times 6. So, of course, if you simplify this one, this becomes 12x equals to 60. Again, you'll get the same answer. The same, so meaning the left side is equal to the right side. They are just the same quantities. That is for the multiplication property of equality. Now for the division, if a and b and c are real numbers, and take note that c must not be equal to 0, and of course they must be real numbers, and assume also that a and b is equal to both sides, then a over c, or a divided by c, will be equal to b divided by c. Okay, example, if we have this one for 4i, let's say 10. You know 10 is equal to 10, right? Now, if you divide, let's say 5 to both sides of the equation, 5 is not 0, right? So we are allowed to use 5 because 5 is not equal to 0. Now, if you divide 5 both sides, so that becomes 10 over 5 equals 10 over 5. Indeed, they're just the same because this one is 2, this one is 2, and of course this one is 2, right? So this one is just the same as this one because that is 2, which is equal to 2. Okay? One last example for the division property. So let's say you have 4x equals 16. Okay? So let's say 4x equals 16, and you want to divide, let's say, both sides of the equation by 4. Okay? So this becomes, if you want to divide both sides by 4, this becomes 4x over 4. That's equal to 16 over 4. So according to division property of equality, this expression is equal to this expression, which is 16 over 4. If you're going to simplify, it's okay. You'll have just cancel this out. 4 divided by 4, that is equal to 1 to 1x, and you know 1x is just the same as x, right? So now this becomes x, and so 16 over 4 will become 4. Okay, now we will use these properties I up to 4i. Maybe we can apply I, 2i, 3i in combination, and so on. We cannot always apply all of them in one example. We can, but we can apply multitude of properties in one equation. So we will try to do that later. At least we already knew what these properties are. Now, first, before we do that, let's proceed to another concept, which is called the linear equation. Now, here in this lesson, we will only deal with the so-called linear equation. We will not deal with much sophisticated type of equation. So we have here a linear equation. Now, a linear equation is the very simple type of equation, a very simple type. A linear equation in one variable, because we will deal with only one variable or one unknown. Okay, those variables are, of course, you know already. Those are the letters. Okay, those are called variables or unknowns. In one variable, a linear equation in one variable is an equation, okay, that is equivalent to one of the form ax plus b equals 0. If you can transform an equation in this form, then that equation will be called linear equation, where a and b are, okay, where a and b are real numbers and x is our variable. So again, if you can transform your equation in this form, then that equation will be called linear equation. So as you can see, linear equation, the highest exponent for the variable in a linear equation is 1. Okay, so that's the indication that our equation is a linear equation. Okay, so we will deal with this type of equation later. How to solve this one. Now we have some examples of linear equation. First, we have this one. 4x minus 5 equals 3. This one is classified as a linear equation. Why? Because this equation can be transformed in this form. Okay, you can do that by using the properties we have learned in our theorem in the last slide. So if you want to transform it in this manner, so of course it's obvious that the right side should be equal to 0. So this one is not 0, but all you have to do is to apply the property above. So to make the right side 0, of course, what we'll do here is we will apply the subtraction property of equality. So this becomes 4x minus 5, that's 3. So what we will do here is we're going to subtract 3 both sides. So we will apply the subtraction property, the 2i, if you can still remember. Okay, we will apply 2i. We will subtract. Our c there is minus 3, all right? Or 3, okay? So because you can subtract any number both sides, so I choose 3. So simplify, this becomes 4x negative 5 minus 3, that's negative 8, equals to 0. So as you can see now, this one is our new equation. Actually, this one and this one are just the same, equivalent, okay? So as you can see, this one, we have our new equation that is in this form. Therefore, this one is a linear equation since its equivalent is in this form. Okay. But one easy way to identify whether that equation is linear is that the exponent for x is, the highest exponent is 1. So that's an easy way to see whether that equation is a linear equation or not. For number 2, we'll just do the same. So here, we will make our new equation of this form, ax plus b equals 0. So since, as you can see now, 4x, that's ax, minus 8 is actually, this becomes 4x plus negative 8 equals 0. So meaning our b here is 0. B is negative 8. Okay. So yeah, it's just the same. Okay, so we have this one, 2x. So we will just, what we're going to do here is we are going to subtract 1/2 x to both sides so that we can cancel this out. So this will become 1 minus 1/2 x equals 1/2 x minus 7 minus 1/2 x. And then you're going to simplify 2x minus 1/2 x. So in other words, we're going to subtract 2 minus 1/2. So that is 3 over 2. Okay, that's 3 over 2x. 1/2 minus 1/2 minus 1/2. So that is 0. So that's 0x. So you just have to cancel this out. And we are left with negative 7. So to arrive in this form, of course, we are going to add. So we will apply the 1i, property 1i. So just add both sides of the equation by 7. Why is that? 3 over 2x, we are going to add both sides by 7. Why 7? Because that will make our left side to be 0. So now that will become 0 now, and this one becomes 3 over 2x plus 7. So now we are in the form of ax plus b equals 0. So this one is just the same as this equation. This one is in this form, therefore this one is a linear equation because this one and this one are just the same equations or equivalent. Okay? And lastly, and again, as you can see, you can easily spot whether this one is a linear equation since the highest exponent for x is 1. And obviously, number 3 is a linear equation. Okay, since the highest exponent for x is 1. And of course, x is not in the denominator, alright? X is always in the numerator. So, the denominator of this is 1. So, yeah, it's alright. So, 3 is also an example of a linear equation. Now, what are some examples of non-linear equation? So, non-linear. So, of course, number 1 is not linear or non-linear because the highest exponent is 2. In our definition, the highest exponent is only 1. Number 2 is not an example of a linear equation because this one is actually equal to x raised to 1/2. As you will see in your, as you will learn in your advanced mathematics, this will become x raised to 1/2. The exponent is a fraction, and we don't want that here because the definition says that the highest exponent is 1, not 1/2. Although the highest exponent here is 1, but we have a variable whose exponent is a fraction. And we don't want that to happen because by definition, the linear equation is in this form, right? The only exponent, the only and the highest exponent for x is 1. So meaning number 2 is not an example of linear equation. Now for number 3, although the highest exponent for x is 1, but we have a variable or unknown in our denominator, and we don't want that to happen because this one is just equal to 3x raised to negative 1 minus 2x equals 1, and it's obvious that there is no such thing here as having a variable of negative. Okay, so in other words, we don't want a variable of negative exponent. Okay, so that is just equal to 3x raised to negative 1/2. Although the highest exponent is 1, but there is no variable here having negative exponent in our form. So obviously it's not a linear equation. So these 3 here are examples of nonlinear equations. So in our next video, in the next part of this video, we're going to solve some simple linear equations. So that would be all for this video. Thank you very much and have a nice day.